When you are considering doing earthing in a building, you have to also consider the cable size. The cable size is important because when you have short circuit, the voltage actually increases. So the cable size that will actually arrest those short circuit faults, those leakage current faults to the general mass of the earth, you need to consider the cable size, and you need to use copper cable, because like what I told you before, that copper cable has a very low resistance and does not reduce the electric current flow. Copper is a very good conductor of electricity. It does not reduce current flow and has a very low resistance. And some materials produce great amount of heat, like iron, which is let me say, like your ring boiler. That is a typical example of converting electrical energy to heat energy. So material produce greater amount of heat. That is why I told you about that galvanized earth rod, because those ones that we see in the market, we're going to sort out materials for earthing. Those ones that you see that is look like copper, most of them are painted. They are not copper, they are iron. So this galvanized steel rod is not iron. It does not corrode easily, and that is why I love using it for my earthing job. And so, like, if you are using iron, it will rust, and that will lack that connectivity to the general mass of the earth. But when you are using copper, you have your galvanized earth rod that does not rust easily. You have your charcoal, your salt that produce more conductivity, and you have your charcoal that retain the moisture of the soil. Then you are good to go. And one of the main points for you to test your earth locally, yes, I want you to learn this today. If you want to test your earth locally, this is very simple to do. Once you are around the DB area, for example, now this is my DB area. You can see we have 2 DBs here because we are planning to do inverter and normal electric power. So once you are in the DB area, this is the earth cable that we have run to this place. Now remove the neutral from the neutral block at the DB. When you remove the neutral, then add this earth to the neutral. Everything will work smoothly as if you add a neutral, because that earth serves as a neutral now to your DB, because it has a zero potential. And you know what is zero potential? It does not shock. So to know if the earth is very, very effective, just remove your neutral, then add that earth that you have sink to the ground to your neutral block. All your lights, all your sockets will work hard fine. Then you will know that your earth is actually very, very effective. You see, the ground is very, very strong. It's even very hard to even retain moisture. Very, very difficult to retain moisture. But it's good. It's going smoothly and slowly. Going smoothly. So as you can see, you sure very break, you not go file am, abi? Okay. You're not smooth for you're not ground down. Now the break shovel. So that is how it is. So the process will continue. Thank you for listening.